All right, practice final exam. This is question number 32. What's the difference between the following two regression equations? Well, one is for the statistics, and then one is for the parameters. So let's see. The first equation is for population. Nope. The first equation is for sample because y hat is a statistic. So we're b sub 1 and b sub 0. So then the second would be for the population because you're using parameters there. A sample of 40 women is obtained and their heights in inches and pulse rates in beats per minute are measured. The linear correlation coefficient is that number. You know what? This may have been a question I already did a video for, because remember how I told you that these are pooled questions? I think I did a similar one to this. I don't know. Or just earlier in the summer when we were talking about chapter 10. Either way, I'll just go through with it anyway. The linear correlation coefficient is this, and the equation for the regression line is this, where x represents the height. So you're predicting the pulse rates. The mean of the 40 heights is this, and the mean of the 40 pulse rates is this. So even though we don't have the original data, they have at least found x bar and y bar. I'm sorry, y bar. Find the best predicted pulse rates of a woman whose height is 71 inches tall. Use a significance level of 0.01. All right, well, let's see how strong that R is. Essentially, we assume that there is no correlation. That's our hypothesis. We test against that. And if the critical value is, if the R value is greater than the critical value, that means that we will reject the null. So we will assume correlation, linear correlation. Okay. Let's see here. It was 254 thousandths. How many? The mean was 40. So it's sample size is 40. Oh, it said right there in the beginning. Going down to 40. And by the way, I'm going to lose this. So I'm looking down the second column because that's where the significance level is 1%. Going down to 40, I've got to beat 402 thousandths, and I've only got 254 thousandths. That means my R value isn't large enough to reject the null, so I can't, and then I can't say that I've established correlation. So if there isn't correlation, or the pattern wasn't linear, or what's the other one? Let me just go ahead and pull up the PowerPoint that I'm trying to visualize in my mind. So it was this slide right here. And the other thing that I haven't thought of is if the prediction is far beyond the scope of the available data, then we have to say that the regression equation is not a good model, and we follow this part of the flow. So we're going to fail this middle bullet, but it could have been that the scatter plot wasn't linear, or that we were beyond the scope of the data. All right, so if we're going to follow this part of the flow, then regardless of the value of x, the best predicted value of y is the y bar. And that's why they had to feed us this little bit of information right here, the mean of the x's and the mean of the y's. So we're going to say best estimate 73.3 beats per minute. Even though they're talking about a woman who's 71 inches tall, I don't care if she was 71 inches tall or 60 inches tall or whatever. still our best estimate. Number 34. Oh, this is I don't think we've done any videos for this. This is a classic. So use the pairs of values for all 10 points listed here. Find the equation of the regression line. After removing the point with coordinates 2, 9, and you'll see, or maybe you can't, but 2, 9 is this little outlier one. This is the only one that's actually keeping some sort of a linear pattern from this point to this bunch of points that says that you could draw a line. If you remove that outlier, you really have no linear pattern, no quadratic pattern, no quartic pattern. You don't have a fit. So you're going to remove that one and then run the same stuff with the 9 points and see what happens, and then compare. So let's do it. Let's see. Oh, I've actually got to put them in. Okay, I'll do that. So let me open StatCrunch. And I'm not going to make you watch all the steps. Okay, I think I can put these together. So I'm going to type in all the x values first, and then all the y values, and I'm going to make sure that they are ordered. First one, I'll go ahead and list 2, 9, and then we've got 4, 2, 4, 3, 4, 4, and so on. 4, 2, 4, 3. And you don't have to put them in any particular order in the terms of this one being 4, 2 and this one being 4, 4. But I may need to make sure that 4 goes with 4 once and 4 goes with 2 once and so on. So let me just go ahead and fill it out. And there it is, the way I listed them. You could have listed them differently. Just make sure that x's and y's correspond. Okay, I'll go stat, regression, linear, and right now my visual of the data says, oh, there's a somewhat of a linear pattern here, right? You got this bunch and then it draws down to this bunch. Or you got this singular and draws down to this bunch. So I will list x's and y's and run it. And I believe I should get the whole thing here. Now, so I should have used my labels, but here's our regression line, where this is y hat, this is b naught, and this is b1, and then this is x. So there's our line, or we could just have taken it this way. Here's our b naught, and here's our b1. So this is kind of like our mx plus b. There's our line. And you can see that line right here, and it's because we have that point up there. Keep that in mind. So let me go ahead and put that in. Three decimals. So I guess okay, what is the equation for the regression line for the set of 9 points? Okay, so we take out oh, by the way, I just talked about this, and I didn't go through the details of it, but the regression line graphed from the scatter plot needs to show some sort of a line. Well, it does with this point here, right? So we've got that. Next qualification is that the R value, the correlation coefficient is supposed to be big enough, right? Indicate that there's correlation. I didn't actually take the time to check that, so let me do that. So I'm not using a specific, I'm not being given a specific level, the significance level. So I'm going to go ahead and just make it as strict as possible and make it 1%. So if you use 1%, and this is a sample of size 10 right now, remember, then I have to be able to beat 0.765. And I have 0.696. Remember, you're looking at the absolute value. For 10 numbers. Well, I guess I'll just assume that I'm using a 5% significance because I know that they're planning on us progressing through this. So if I use 5%, then I have to beat 0.632. And we've got 0.696. So it does. And then the last one is that I've got to be, I'm not predicting much beyond the value, and then I can use this. All right, so that's my justification for filling in the line. What is the equation without that? Okay, now let me go back to this. Let me see how I can do this. I want to eliminate this entire row because that's the one with that one. So row, delete. Sorry, I have an old window up. Okay. So it's under edit, row, delete, 0 rows. I want that one. Okay, it looks like it worked. Now I'm going to run stat, regression, linear, x, y. So now my line is 3 plus 0 for my slope. Why 0? Well, it's a result of our correlation coefficient also being 0. If r is 0, then when you multiply by the sample standard deviation of the y's over the sample standard deviation of the x's, that whole thing is going to turn out to be 0 too. So b1 is going to be 0. So we've just got 3. And that makes sense because, you know, without this point, there isn't correlation there. So choose the description of the results below. The regression line is very similar in both cases. No. There is no regression line for the second case because the data are in a pattern. Because the data are in a pattern. The removal of the point has a significant impact on the regression line. Yeah, that's for sure. The regression line changes, but the change is small. No, it's a big change. We completely lost our slope. So I'll go with the removal of 1 point. Now, it's the removal of a significant point, like the outlier, that really makes that happen. All right, let me go ahead and submit these 3 questions because it's gone a little bit long again. And nothing really to talk about. All 3 correct with no partial credit. So check those out if you want them.